Welcome to this Frequency Matters podcast. I'm Pat Hindle, and I'm here with my co-host Gary LaRude. This is our first podcast in our new series with Molex on 5G technologies, and today we are exploring 5G mobile device design challenges. To discuss this subject with us, we have Stephen Drinan, Director of Core Products for Antennas and Micro Solutions at Molex. Welcome, Stephen.
Thank you, Pat. Great to meet you and Gary, and I'm happy to be here to talk with you today.
So let's just get started with what is driving the build-out and demand of 5G networks, just so we can get an overall high-level view of what's going on in the market.
Yeah, sure. In the last couple of years, what we've seen is that really the industry has shifted from what we would call the connected era to the data era. And really what we talk about there is shifting from that heavy focus on connecting devices, where everyone wanted something connected, everyone wanted something flowing, and now really working to see how we can use that data to deliver information and services that actually improve our lives. So 3G and 4G really gave us that connected era, and LTE ushered in the era of data, allowing for a lot more connectivity and some really exciting services. Things we can bring to mind are things like the Netflix, Hulu's, Apple TVs, services that we never thought would ever be enabled or envisioned under 3G, for example. And when we talk about 5G now, what we often hear is that this will be an everything network, available everywhere, available for everyone, and with the added bonus of being able to provide data at high data rates and low power consumption, which is going to be really important for a lot of remote devices, sensors that need batteries that last a long time, that we just can't climb up on a ladder and change out every other day or plug in and charge. So that's really going to help enable a lot of that. And when we talk about the three groups and what's really driving that demand for 5G networks, it's broken down into three areas, and I'll just touch on those for a minute here. The first one being enhanced mobile broadband, and this is really talking about those gigabytes in a second on your smartphone. And what that's really targeting is those who want to really live a digital lifestyle. So when we talk about that, we mean those who want to live in a world of, or play in a world of VR, AR, maybe not quite live there yet, but come back and forth in and out of that, enjoy their high definition, 8K and beyond videos. So that's really going to enable that and drive that forward. The next one then being massive machine type communications. So that's a mouthful, and if we just think about it simply, it's connecting a huge amount of devices. And I think a lot of us don't really think about what we mean by a huge or massive amount of machine type communications. We're talking about every lamppost, every corner of every building, every traffic light, everything connecting together. So your smart cities, warning you not to cross the road, telling cars to slow down or prompting them to slow down, enabling agriculture to be connected, in rural areas, so we can get better yields on crops, lower costs of food, and things like that. So quite exciting from that area. And the last one, which is probably the one we hear a lot in the news about, is kind of that ultra reliable and low latency communication. And again, another mouthful, but what are we talking about? We're talking about connections that never drop, with key data that's going to really, really enable secure connections, high-speed connections, so that's almost real time. So the kind of applications that are driving that are going to be your self-driving car, and then remote management in factories, power plants, things like that, where you want real, secure, reliable connections and high-speed communications. So again, just after highlighting those three, it might sound like, again, we're just building more connections and we're just adding more things into the system. But in reality, this time with 5G, what's really being hunted, or really what we want to get to, is the data, how we can get that data and then realize new services and new ways to improve our lives with that data. And I think that's really what's going to be exciting as we go forward, and that's truly what's driving the demand to bring those services to our lives and just enable better decisions for ourselves, safety in the community, and just keep advancing that way. So when I think about the deployment of these 5G networks, especially in some early adoption regions, I think this will really spark more innovation around those services. And then what will happen there is that in turn, that kind of innovation of the services will spark, the need for expanding that deployment of the 5G network. And that again will start the cycle of new innovation of services and information flow. So I think it's going to be this snowball that just keeps going for the next 10, 12 years.
Well, you've painted quite a compelling story for the impact that 5G is going to have on our lives. If we focus on the mobile devices, what technologies are required for the mobile devices to meet the expected performance levels that you've outlined through the new network capabilities?
Yeah, thanks, Gary. It's a good question. It's definitely a complex one. And if I go into all the details, it'll definitely be beyond my capabilities. I'd have to pull in a lot of our technical experts on that. But really, if you look at what's happening in the market, you've got a lot of the leading OEMs and RF module providers working tirelessly to figure this out. So the network build-out approach and strategies actually are the ones that are going to drive what happens in the smartphone. So if we talk a little bit about maybe the network implications first, the first thing is probably for us to be aware of is that 5G is going to have to work seamlessly with gigabit LTE and Wi-Fi 6 connections to deliver that seamless type of connectivity. So this is what's kind of referred to as a standalone and non-standalone network. So your standalone being that pure 5G super mega high-speed connectivity, and then your non-standalone being that switch on and off between LTE and then back to the 5G network. So for true mobility, as the modem and the devices moves in and out of the range of 5G wireless networks, it's going to have to be designed to switch in and out of that. And that's ultimately what's going to drive the impact on the mobile devices and then what's going to be inside on those. So when we think about that, we'll need to have architectures and modules and components inside a mobile device that's going to support those different networks. So again, those being a mix of LTE, the 5G, and then a Wi-Fi 6. So your logic boards are going to be continuing to get much, much more crowded. The real estate price and the space is going to continue to go up. And that's going to create this battle inside, for the designers, for those OEM smartphone makers. Your battery designer will be fighting with the PCB designer for space. They'll be fighting with the camera guy. And they'll all be fighting with the person who's trying to manage the heat dissipation inside there, because they're causing all the trouble for that designer. And so I think that's going to be the interesting battle as we go forward. So if we talk about key technologies inside there directly linked to the 5G, we can talk about the 5G Rf Modem. That's obviously a key one and a critical one. And these are modems that are going to have to support the full spectrum. So that means they're going to have to support the sub-6 gigahertz. And to do that today, even before 5G, because of the high amount of data transfer that's going through the antennas, the smartphone designers are having to use MIMO technologies and 4x4 MIMO antennas to realize that. And then as we move ahead with millimeter wave coming into the phones, that's another complexity where there'll be MIMO antennas used there in a 2x2 array. And that will be paired with beam steering and tracking to ensure that we can have that connectivity at these high frequencies. So it's just going to get more and more packed in there, and everyone's fighting for that real estate. It's just going to be this constant fight to keep costs down as well, which is going to be a super hard challenge.
So given that, describe the changes to the architecture and the layout of the phone that are coming.
Yeah, as I mentioned, right, the boards are going to continue to get more and more crowded, and that's going to be the battle. But if we even think before 5G, the demand for processing more data faster has been there, and that's driven by the services we mentioned earlier, the Netflix, the YouTubes, TikTok, Instagram, WeChat, and all the services that they provide. So if we think about that processing of data faster, and then the data transfer capacity through the antennas. What we've already seen up until now is like smartphone makers stacking PCBs on top of each other, having to remove shields over the ICs to make the device thinner. This has other knock-on effects where you have to then put grounding in other features, other parts of the board to handle issues there. As mentioned, like the MIMO antennas used for more sub-6 cellular antennas. And then the move recently in the last few years from coax cables and traditional RF coax connectors to new materials for the transmission lines, and then RF board-to-boards in order to save space on those boards as well. So those are things we've already seen. So what we're going to see now with 5G being pushed in is all of that, plus trying to fit in your millimeter wave RF antenna modules. And you're going to see, typically at least 3 of those in a device in order to get the right amount of connectivity. So that's taking up more space, adding to the complexity of the antennas, and then leading into more complexities around signal integrity inside the device as well.
So moving back to the network side, why is the number of cell sites expected to be 10 times the number of the 4G cell sites?
Yeah, I think this brings us back to the kind of topic of 5G being that everything network for everyone, everywhere, all the time, always connected. And we know 5G is going to have to leverage millimeter wave frequencies to get that high speed of data transfer. And the catch with millimeter waves really is that they just don't travel as far as the sub-6 gigahertz waves. They're more easily absorbed or blocked by materials. These could be trees, buildings, even rain. I think back to when I was much earlier in my career and be calling home. I'm originally from Ireland. I'd be calling home to my parents and they tell me the signal's bad. It must be the weather. I thought they were crazy, but they've proven me wrong. They knew 5G was coming before I did. But yes, simple things like that can impact the performance. So this is a significant risk to the connection and a signal drop. And you can imagine as a consumer, if you've paid, a subscription fee every month to have this connection, and there's rain blocking your signal, and you can't get your NFL sports streamed live, or something's being dropped out, you're going to be quite frustrated. So they're going to have to overcome that. They have some techniques and technologies, of course, with the beam steering and tracking. But really having those small cells much, much closer to the device user and the consumer. And we're talking, closer 200, 300 meters and in the same building. So getting those really close to the consumer, connecting into their phone, making sure they have the service at all times is really what's going to drive up this huge amount of small cells everywhere.
So I tend to think of outdoor deployments, and as you mentioned, weather and foliage and so forth. Talk some about what the implications are for indoor deployments as far as the mobile device and the network are concerned.
Yeah, if I'm going to be honest, Harry, I'm kind of interested myself to see how this is going to play out. And this is always a great conversation between the network providers globally, what they're doing in US versus Japan, Korea, and China. And then who they're working with in that ecosystem and how they're going about it. So if we think in terms of, like, let's take the home, for example, I kind of have to be honest and say, I'm not sure from my personal needs that I see a need to have a 5G small cell in my home in order for me to do the things I want to do. If we think about Wi-Fi 6, already supporting up to maybe even as high as 4.8 gigabits per second, that's going to really enable a lot of high-speed connectivity for you anyway in the home. Now, you'd want to be pushing on to have something really heavy data, probably playing live VR games with your buddies from New York to here, Tokyo, playing live at the same time and trying to do that. So I think in the home, it's going to be interesting to see how it plays out. But I think areas where indoor is going to utilize 5G more are things like concerts, arenas. And if you think about maybe large airports where you have, thousands of people trying to connect, everyone panicking to download that latest show on Netflix before they get on the plane. I've done it myself a million times, been walking down the exit door to go out and hitting that button and watching to see when the captain announces to close the door and hoping I get that movie downloaded. But that's the kind of thing that will drive some of this. And then, it'll kick on from there. That'll bring more ideas, more areas to bring services, and eventually they'll come into the home and they'll come into the workplace as well.
So why is the mobile device antenna technology so important and different with 5G?
Yeah, I'm glad you asked, because so many people talk about the complexity of the antenna design and base stations, repeaters, small cells, and it's true. Those are highly complex and a lot of people working together to figure it out, and it's going to take a lot of collaboration. But the devices also need to change, right? And there's a lot of discussion and activity in trying to solve that as well. Everybody wants to be the expert and everyone thinks they are the expert, and there's kind of a clamoring to get control there. So, with Sub-6, we already do see, more antennas to accommodate the desire for more data transfer and the capacity there. Again, you're seeing those kind of 4x4 MIMO arrays being used in phones today. When we really talk about the difference maker in antennas in the devices going forward, it's really going to be the millimeter wave frequencies in those antennas. So it's important for us to really recognize that designing for the millimeter wave, 5G requires attention not only to the antenna, but also to the feeds and connections that go into that antenna. And these need to be rated at speeds that are exceeding 10 gigahertz. So to get signals from 5G electronics on each device, it will, require attention to the end-to-end signal integrity for those devices. And a focus on the signal integrity really is essential to how well these devices perform and can utilize the ultra high speed of 5G signals. So a good example here is what you'll have seen over the past couple of years on smartphones, that even at 4G speeds, the introduction of new materials for the FPC signal transfer lines and the antennas themselves has changed from polyamides to LCPs, and now again moving to modified polyamides to reduce the cost to try and get more cost-effective product into the hands of consumers. And this is all an attempt to reduce those signal losses. It's also going to help save space in the phone and then give some of the OEMs more freedom of design, as those FPCs with LCPs and modified polyamides are much more flexible and bendable in the phone to allow better routing inside there. And now with the millimeter wave 5G speeds coming, that are really, 10 to 100 times faster, it's critical for the antenna designers and the suppliers of those products to be able to design, for the whole solution. So that's that end-to-end signal integrity problem. You can see with the RFIC designers, they're taking an approach with millimeter wave, that they want to have everything together in one module because they see that criticality. So at Molex, we're quite lucky in that regard. And we've already have a very strong design capability in high-speed connectors for datacom. We have RF connectors today for antennas going into base stations and also going into other consumer devices. And then where I'm focused, the micro board-to-board or board-to-flex connectivity, along with mobile phone and consumer device antenna design. So really pairing all of those together and using those capabilities, we've had to kind of rethink how we design products and actually how we reorganize our engineering teams. So in the past, you'd have engineers on the antenna group working in isolation by themselves, just working on an antenna problem. You'd have the board-to-board or board-to-FPC designer doing his thing. But today, we bring the groups together and sit with customers, talk about their problems, and then we're able to move forward and solve their antenna board-to-board connectivity and then the signal integrity side. So it's different for us. It's different for our customers. We see them also trying to reorganize their engineering groups to do a similar thing. But ultimately, it actually is leading to a lot faster designs and better designs in the devices because more groups are talking together. So in the past, instead of two groups, one connector group talking to an OEM smartphone maker, you have an antenna group, a connector design group, a signal integrity engineering group talking to their counterparts in one group. So a total of 6 groups together, and it actually enables for some really fast and exciting design iterations. So we're excited about that, and it's something I think our customers are also excited to see when we work on these things, because again, the solution and the problem, it's not easy. So getting all those heads together is really, really helping.
I'd like to explore a couple more aspects of the design challenges that need to be addressed by the antennas. And you've mentioned some of this, but for example, at millimeter wave, the need for beam steering, and then we see the additional frequency bands, sub 6 gigahertz to support 5G, and of course the LTE bands aren't going away. So how are the antennas needing to respond to this proliferation of bands sub 6 gigahertz?
Yeah, so if we talk about the need for beam steering, that's heavily being implemented and controlled by the module makers for the modems. So having to work very, very closely with them is critical. And so our focus really there is understanding and being able to design for passive antennas, and then looking at the RF circuitry and layout around that, and having the knowledge to knowing how to connect in and work with the leaders in the RFICs that are integrating those beam steering technologies. So we just have to work in a partnership and keep marching forward and doing that. And we know what our expertise are, and we just work with our customers and what theirs are.
So can you tell us about what are some of the testing challenges and how we'll be able to meet these requirements and verify them?
Yeah, Pat, for sure. When we look at the mobile smart phone devices, it's really different for us how we're having to approach it now. So in the past, because of the micro connectors that are in those phones, you really don't have to worry about signal integrity with such small, amount of metal that's going through those connectors. But that's changed today when we're enabling those connectivities with 5G millimeter wave frequencies. So what we're noticing is that combining our knowledge of signal integrity testing, also then with our 5G millimeter wave chambers and our RF test capability there to conduct, far field testing to ensure that we're actually keeping the signal inside the connector and keeping it inside the FPC. And we're finding that key to make sure that when a product actually ships to a customer, it's going to do exactly what they need, and we're going to keep all of that signal within the device and not lose it to the surrounding areas.
So how do you see the rollout of 5G devices progressing over the next few years?
Yeah, I think it's a really interesting one, Pat. And I think, again, it comes down to the services that people can imagine and actually deliver to excite demand in the market for 5G. So when I think back to 2013 and 2014, at that time, everyone was very, very excited about designing their own smart watch or smart wearable something. I think almost every company was trying to do it. But the limitation they had was they didn't know how to use the data. And if I'm going to be very honest, I wear, my smartwatch every day. I work out, maybe not as much as I should. And I look at the data, I look at my heart rate, I look at the calories, I track my sleep, it gives me a number. But at the end of the week, I'm really not sure what to do with that data. I just kind of look at it and go, wow, okay, I have data. And I think we saw that with that for quite some time. And a few companies have figured it out, and they're, providing services to help professional athletes and those that, like myself, who would like to believe we're somewhat of a professional athlete, but definitely not. And so I think really the rollout's going to be driven primarily by those services that people enable and how they use the data. I think the appetite for the network providers to roll out in big cities, of course, is there. But when we think about across the nation and across the globe, and in smaller countries like where I'm from in Ireland, in rural areas, there's not going to be that push out for 5G unless there's that true demand for those services. So if we think broadly beyond, the New Yorks, the Chicagos, the San Franciscos, LAs, Tokyos, really to go beyond that, it's going to be the services that's going to drive it. And I think it's not going to be, this fast push out that happens. We all wake up on January 1st, 2021 or 2022, and we go, finally 5G is here and it's everywhere. It's going to be kind of this creep. And in many ways, you're not going to fully notice it coming in, again, because you're leveraging LTE, you're leveraging Wi-Fi 6 and working that together with 5G. But I think at some point in about 7, 8, 9 years from now, we'll look back and realize, we were like cavemen living in our homes and our apartments we're living in now, and how unconnected they were, and the lack of services and help we had in the home. So that's really what I'm excited to see about the rollout coming, and how it's going to go forward.
Well, you're right. These are exciting times for the industry as 5G rapidly deploys. Thank you, Stephen, for joining us to talk about 5G mobile device design. We appreciate you giving us a view into 5G technology and the design challenges and what Molex is doing in this area.